Hello and welcome back to another video. Here we are going to solve last three questions from October-November 2020 970962, that is probability and statistics 2. And here is the question number 5. Customers arrive at a shop at a constant rate of 2.3 per minute. State another condition for the number of customers arriving per minute to have a Poisson distribution. So we know that it should be independent, it should be random. So we can say customers are coming at random. We can include anything, or we can say they are coming independently of each other, or they are coming singly, because in the Poisson the probability of simultaneous occurrence is 0. So that's it. Let's discuss this one. It is now given that the number of customers arriving per minute has a Poisson distribution 2.3, PO 2.3, with this 2.3 as the lambda. Now find the probability that exactly 3 customers arrive during a 1 minute period. So in this case lambda is given as 2.3 per minute, because they have given it as per minute, and hence this is, let's say x is the number of customers, so it will be a Poisson distribution with 2.3, and hence the probability we need to find is probability of x is equal to 3, which is of course e raised to the power minus lambda 2.3 into lambda to the power 3 upon 3 factorial. So we will solve this, and this is 0.203 till 3 significant figure. Here's the C part. Find the probability that more than 3 customers arrive during a 2 minutes period. So earlier this lambda was 2.3 per minute. So in 2 minutes period this lambda would be 2 multiplied by 2.3, that is 4.6. So our probability question becomes finding the probability at least more than, so greater than 3, which is 1 minus probability of x is less than or equal to 3. So it is 1 minus e raised to the power minus lambda, that is 4.6, 1 plus 4.6 plus 4.6 square upon 2 factorial plus 4.6 cube over 3 factorial. So now we will calculate this. 1 minus 0.3257 and so on. So we will subtract it from 1, and this value is 0.674 till 3 significant figure. So I hope it's clear. Let's discuss the next question. 5 1-minute periods are chosen at random. Find the probability that no customers arrive during exactly 2 of these 5 periods. So for 1 minute period the lambda was 2.3, and we can see it's 2 out of 5, so it's a binomial. But before that, in binomial we require p and p here, and the p means the probability that no customer arrive, and probability of no customer arriving from the Poisson we can find, and that is going to be finding the probability of x is equal to 0 when this x was with Poisson 2.3. So it is e raised to the power minus 2.3 multiplied by 1, that is this only, and hence q of it is going to be 1 minus e raised to the power minus 2.3, and hence the probability we are going to find is x, probability of x is equal to 2, exactly 2. So it is 5C2 success probability to the power 2 and failure probability to the power 3, and hence it is 5C2 is 10, P square means e raised to the power minus 2.3 whole square, cube is 1 minus e raised to the power minus 2.3 whole cube, and this value is 0.07321, so 732. That's the answer.
And here is the question number 6. A biscuit manufacturer claims that on average 1 in 3 packets, that is the proportion of biscuits contain a price offer. Gary suspects that the proportion of packets containing the price offer is less than 1 in 3. In order to test the manufacturer claim, he buys 20 randomly selected packets. He finds that exactly 2 of these packets contain the price offer. Carry out the test at 10% significance level. So first one, we will take null hypothesis as proportion P as 1 in 3 means 1 over 3. It means we can calculate Q also, and then alternate hypothesis, because he wants to claim that this is going to be less than, so P is less than 1 over 3. That is the alternate hypothesis. Now we will write that we need to will reject H naught if probability of X, see if here the X is binomial with the parameters n is 20 and P is 1 over 3, and here if it is true, then it will reject H naught if probability of X less than or equal to 2 is less than, for 10% it is 0.1. So we will reject H naught if this probability is less than 0.1. So let's find the probability, and the probability for X less than or equal to 2 is going to be probability of X is equal to 0, 1 and 2, and that is going to be 20C0 P, that is 1 over 3 to the power 0, and Q would be 1 minus 1 over 3, that is 2 over 3 to the power 20, plus 20C1 1 over 3 to the power 1 and 2 over 3 to the power 19, plus the last one 20C2 1 over 3 to the power 2 and 2 over 3 to the power 18. So we will simplify it, and this value from the calculator is 0.017592 and so on. So we'll, and till 3 significant figure, this value is going to be 0.0176, which is going to be less than 0.1. So we will reject H naught. So we'll write reject H naught. Reject H naught means we are not supporting the manufacturer claim. So we'll write there is no enough evidence at 10% significance level to support manufacturer claim. I hope it is clear. Let's do the next part of this question. Here's the B part. Maria also suspects that the proportion of packets containing the price offer is less than 1 in 3. She also carries out a significance test at 10% level using 20 randomly selected packets. She will reject the manufacturer's claim if she finds that there are 3 or fewer packets containing the price offer. Find the probability of type 2 error in Maria's test if the proportion of packets containing the price offer is actually 1 in 7. So it means it's given that she will reject the manufacturer's claim if she finds that there are 3 or fewer packets. So it means rejection region we can write from here. Rejection region is going to be x less than or equal to 3. That is x is equal to 0, 1, 2 and 3. So we will, for the type 2 error, we will take acceptance region, which is going to be x greater than 3, and it is going to be binomial. But now the new alternate, like we are going to commit the type 2 error. For the type 2 error, we are going to reject the h0 even if it is true. So in the acceptance region, h0 is true. It means in the acceptance region p was 1 over 3, but we are rejecting it and we are taking p as 1 over 7, which is given. So this, now the new probability distribution would be binomial with 20 and success probability is 1 over 7. So the probability of type 2 error is going to be finding the probability of x is greater than 3, which is 1 minus probability of x less than or equal to 3, and which we can calculate 1 minus, it is going to be 20c0, 1 by 7 to the power 0 and 6 by 7 to the power 20 plus 20c1, 1 by 7 into 6 by 7 to the power 19 plus 20c2, 1 over 7 square and 6 over 7 to the power 18 plus the last 20c3, 1 over 7 to the power 3 and 6 over 7 to the power 17. So now we will calculate this value. So this is going to be 1 minus 0.6822 and so on. So till 3 significant figure it is going to be 0.682, and now this minus 1 minus this value is going to be 0.3177 and also 318. So the probability of type 2 error is going to be 0.318. So I hope it's clear. Let's do the next part of this question. And here is the C part. Explain what is meant by type 2 error in this context. So type 2 error means we have calculated in the acceptance region of h0. So it's like we are concluding the proportion as 1 by 3, or we can write 1 in 3, but actually it is 1 in 7. That is the type 2 error, because we have taken 1 in 7. So it's like concluding the proportion as 1 in 3, but actually it is 1 in 7. That's the type 2 error. Now here's the 7th question. Before a certain type of book is published, it is checked for errors, which are then corrected. For costing purposes, each error is classified as either minor or major. The numbers of minor and major errors in a book are modeled by the independent distribution. That is normal independent distribution. 33 to 80 and 140 is the parameter for minor, and 210 and 80 as the major errors respectively. You should assume that no continuity corrections are needed when using these models. A book of this type is chosen at random. So find the probability that the number of minor errors is at least 200 more than the number of major errors. So we can take this to as x for minors, so it is normally distributed with the mean 380 and variance as 140, and y we can take as the major error. Again it is also normal with parameter means mu as 210 and variance as 80. So the probability in this way we are going to calculate for x. It is given the number of minor errors is at least 200 more than, so it means it is going to be more than or equal to 200 plus the number of major error. So it is greater than or equal to 200 plus y. So we need to find this probability. So what we are going to do, we are going to make another random variable here by taking y to the another side. It would become yx minus y, and then we will calculate the probability for greater than or equal to 200. So this is another random variable, and we know that any linear combination of two normal distribution is again normal, so it would also be normal x minus y, and the parameters are going to be mean would be mean minus mean of x minus mean of y. So it become 380 minus 380 minus mean of y, that is 210, and variance would be 140 plus 80. We will not take minus here in the variance. So now it is going to be n 80, so 170, and 140 plus 80 is 220. So we need to find the probability of this, probability of x minus y greater than or equal to 200. Now it is given that the continuity correction is not required, so we will write with the standard normal value distribution is greater than or equal to, or we can write greater than, that is completely fine because it's a continuous distribution. So it is 200 minus mu is 170 over sigma is square root of variance, that is root of 220. Now it is going to be probability of z greater than 330 over root 220. Now let's calculate this value. So this value is probability of z greater than, it is 2.0225 and all, so we'll write 23 because we require till 3 decimal places to find the value from distribution. Now it is going to be, we get to taken this 0.225 also in order to get the value nearest to the on the addition column on the distribution table, but that's fine. Now we will draw the distribution graph to see which region we need to find, and it is positive, so 2.023 would be somewhere here, and we want to calculate this probability, and this probability is 1 minus 5 of this value. So it is going to be 1 minus 5 of 2.023, and let's calculate from the distribution table now, and this value is 0.0216 till 3 significant figure. This is the answer. That's the probability. I hope it is clear. Let's do the next question. Now the costs of correcting a minor error and a major error are 20 cents and 50 cents respectively. Find the probability that the total cost of correcting the errors in the book is less than $190. So since the number of minor correct minor error was normally distributed with parameters 380 and 180. Sorry, it is 140. And for minor error, a major error, it was again normally distributed with the value 210 and 80. It is given in the first part. So if these are the number of minor errors and major errors and the cost is given, so the total cost we can take as t. So the cost would be t for t is going to be minor error, this is 20 cents, so it is going to be 20 times x plus 50 cents for major error, so plus 50 times y. Now we will calculate, this is a linear combination of two normal distributions, so it would also be a normal distribution. So we will calculate its mean is going to be mu is same as expectation of t, which is 20 times expectation of x plus 50 times expectation of y, which is 20 into 380 plus 50 into 210. Now we will calculate this value, and it is 18,100, and the variance sigma square is going to be variance of t, it is going to be 20 square times variance of x 140 plus 50 square times variance of y, that is 80, which can be written as 400 into 140 plus 2500 into 80. Let's calculate this value as well, and this value is 256,000. Now the probability, we can write this probability is t less than 190, so t is less than 190 here. Oh sorry, it is dollar. So we will calculate, and it is continuity correction is not required. Again, it is dollar, and this value, it is going to be in the cents, so we need to make them equal. I'll make this as a cents. So t is less than 190 into 100, that is going to be 190.00. Now we will calculate in the standard normal distribution, z less than 19000 minus 18100 over variance square root, that is sigma, it is going to be root of 25600, and now 256,000. Now we will calculate this value, and this value is 1.7787, that is 9. And now we will calculate this value from distribution table, and since it is phi of 1.779, and from the distribution table it is 0.9624, so till 3 significant figure this probability is 0.962. That's the answer, and that was the last question of this paper. So that's it for this video. Thank you so much.